Question 7. When heated, a sample of potassium chlorate produced this much oxygen. What is the amount of moles of potassium chloride as decomposed? So the gas constant R. So we're going to use PV equals nRT. And we're going to find out, so let's write it, PV equals nRT. I'm going to find the number of moles n is PV divided by RT. Pressure in pascals, 110,000 times by the volume in meters cubed, 67.2 times by 10 to the power minus 6 divided by R, 8.31 times by the temperature in Kelvin, 298. That will give you the moles of oxygen. Obviously it's a 2 to 3 molar ratio, so we divide the mole by 3 times by 2, that will give us moles of potassium chlorate 5, and you should get 1.99 times by 10 to the power minus 3. But that's the method. PV equals nRT, look at molar ratio, divide by 3 times by 2, which has a bond angle of 109.5 degrees. Carbon, diamond, very simple. Testing your knowledge of bond angles. Which reaction of enthalpy change equals standard enthalpy of formation of silver iodide? Remember, with enthalpy, it's not ions, so these two are immediately crossed out, so we're left with these two. And is silver in its gaseous state? No, it's not. It's in a solid state, so that's wrong. A is wrong, so therefore it must be B. 10 was the enthalpy change of this reaction in kilojoules per mole to the power minus 1. Well, we're given bond enthalpy, so we're going to use delta H equals energy, or bonds broken minus bonds released, energy required to break bonds minus energy, however you like to help you learn it off by heart. Basically all we're doing is finding energy of this required to break bonds, and then minus energy released when new bonds are formed. All you do is 412 times by 4 plus 2 times by 496 minus 743 times by 2, minus 743 and then times by 2 because it's CO2, and then plus 4 OHs, so 4 times by 463. So it's just a long calculation, and you should get minus 698. So all it requires you is to memorize this formula, which you should know, and then substitute the values in, and obviously consider the moles. But yeah, I'm not going to go through the calculation because that'll just take a lot of time and there's no point. 11. In which conversion is the metal reduced? This one we're going to need to look at oxidation states. Any kind of one marker, we're trying to find out which metal is reduced. Look at the oxidation states of the metal, right? So if we look at the oxidation state of here, Cr2O7 2 minus, well, Cr2O7, well, oxygen has an oxidation state of minus 2 times by 7 minus 14, but we want a minus 2 charge, so it's going to be plus 12, so it's going to be plus 6, and it's going to a minus 8 plus 6. Yeah, so the oxidation state does not change at all, so it can't be A. B minus 8 plus 6 again. Wait. Minus 14 plus 12 gives minus 2 minus 8. Yeah, I'm just double checking. A B minus 8 plus 6 gives minus 2. Yep. And then for the products, well, minus 8 plus 7. That's been oxidized. We don't want that. We want the conversion which the metal is reduced, so it can't be B. C minus 4 plus 4 to minus 6. Oxygen is always minus 2 turned by, well, obviously in some cases it's not, but in this case it is minus 2 turned by 3 is minus 6. Minus 6 plus 4 will give us minus 2. So that's no change, therefore the answer must be D. And let's look at the oxidation state of that, of D, of V. Well, minus 6, so therefore that is plus 5, and it's going to, well, that's minus 2, so plus 4. Yeah, so you can see the oxygen state has gone down, it's been reduced. 12, which statement is correct? Rate constant has units of that. The rate of concentration to half the concentration of X is half than that, and then you've got these. Well, this one is definitely incorrect. D is a constant, so therefore it's dependent of temperature. Temperature does affect constant. Remember, Kc, Kp, temperature affects it. So D is definitely incorrect. So now we're left with 3. The rate constant has units of that. Let's find out. So K is equal to rate mole per dm minus cube s power minus 1 over x squared y, so mole per dm minus cube cubed. So we're left with s power minus 1 over mole to power 2 dm to power minus 6. So it's mole to power minus 2 dm to power mole to power minus 2 dm to power 6 s to power minus 1. So it's not A. B, the rate of reaction is halved if the concentration of X is half and the concentration of Y is double. But let's look at it. Concentration of X is half. What we're left with a half squared times by a concentration of Y is doubled. What's that? Well, that's 1 over 4 times by 2. Which is a half. So therefore B is correct. And then we don't need to look at C because B is correct. Which statement about pH is correct? This one's really complicated. pH of a weak base is independent of temperature. Nope. Dependent of temperature. Again, exactly like D, you can cross that one out. At temperatures above 298 Kelvin, pH of pure water is less than 7. The reason I say this is a really hard one because you need to think deeply for this question. Pure water, so Kw. Well, Kw is equal to H plus OH minus, right? And you also know H plus is equal to OH minus in this case. So we get Kw is equal to H plus squared, where H plus is concentration of hydrogen ions. So H plus is equal to square root of Kw. And Kw increases as temperature increases because there's temperature above 298 Kelvin. So we know Kw will increase. But if Kw increases, what does that mean for H plus? Well, H plus is equal to square root of Kw, so H plus, concentration of H plus ions will increase as well. So what will that mean for pH? Well, remember, concentration of H plus ions increases, therefore pH decreases. And remember the formula for pH. pH equals minus log 10 H plus. As H plus increases, pH decreases, and therefore B is correct. The pH of pure water is less than 7 as temperatures above 298 Kelvin. Because Kw increase, H plus will increase as temperature increases, and therefore pH will decrease. 14. Which acid base pair has the highest pH at the equivalence point? We've got carboxylic acid and sodium hydroxide. This is weak, this is strong. This is strong and this is strong. This is strong and this is weak, and it has the highest pH at the equivalent point. And that's going to be weak. And I'm pretty sure, yeah, that's going to be weak. So the one that's going to have the highest pH at the equivalence point is going to be A. 15. Why is nitric acid added? This is a really nice question because I know the answer straight away. It increases the concentration of nitric ions. Nope. It prevents the precipitation of silver compounds other than halides. Absolutely, it is B. So written equation that you do need to know: Cl2 plus 2NaOH or NaCl plus NaClO plus H2O, which shows a major products form. We've got water isn't a major product, it's a byproduct. We've got sodium chloride and NaClO. NaCl, NaClO. Therefore the answer is C. Again, this multiple choice question is just how well can you memorize stuff, how well do you know the equation. That's all it's testing. And if you don't know the equation, you're gonna have to guess and you're probably gonna get it wrong. Maybe not. 17, which shows the electrical configuration of an atom of a transition metal. Well, this is calcium. This is M2 plus 3D8. This is M2 plus 3D10. Zn2 plus, and this can't be correct because this is in the P block. Therefore, it's wrong. So of a transition metal, it's going to be B. 18, which will not act as a ligand in the formation of complex ion. So what is a ligand? Just remember, donor, right? Donates. So which will act as a ligand, meaning it will donate. Which will not act as a ligand, meaning it cannot donate. So therefore it doesn't have any lone pairs of electrons. Well, forget, if you look at NH3, that has no lone pairs of electrons. NH2 would be H2O also. No, I mean NH3 does have lone pair of electrons. NH4 plus sign. H2O does have lone pair of electrons. Oxygen. So it's either A or B. Well, carbon monoxide, CO, triple bond O, it has a lone pair of electrons. So it can't be B. And CH4, well, obviously carbon can only have 4 bonds. So therefore, it has no lone pair of electrons, cannot act as a ligand in the formation of complex ion. 19. Which shows the correct oxidation state and coordination number of cobalt in this. We've got this and this. Well, chlorine, Cl2, so we're going to have a 2 plus. And therefore this whole thing, that's going to be minus 1. That's going to be plus 3. Plus 3 and the coordination number is going to be 6. Which statement is not correct? I really don't like this. I like to say which statement is false. I don't know why. CuCl42 is square planar. That's false. NH4 plus is tetrahedral. That's true. That's true. CuCl42 minus is tetrahedral. Which compound decolorises acidified potassium mungate? 7 solution. Well, it's going to be the one that's easily oxidized, and it's going to be this C, because Fe2 plus easily oxidized. Therefore, it's going to be C. Which has EZ isomers? Let's draw them out. Let's do A. C1C, and you've got your H's, and you've got your bromals. Now, can this be an EZ isomer? Can it be an EZ isomer? Yes, because these are enemies. And if you switch the groups, they can become on the same side. So is A. 23. Which is the mechanism for this conversion? One thing I know is definitely not A. Addition elimination. No. Well, let's look at it. This benzene has not been affected at all. You've gone from a CH3 to a CH2Cl. Electrophilic substitution, well, electrophilic substitution, nitration, and all of that. Well, you wouldn't lose a hydrogen and gain a chlorine. Free radical substitution, if you have CH3 plus chlorine free radical, CH3 dot plus CH2 dot plus HCl, and we've got CH2 dot plus Cl2 to form CH2Cl plus Cl dot. And chlorine free radical is not used up, so it is free radical substitution. Nucleophilic substitution, well, nucleophilic substitution, I guess some people could go for, some students could go for nucleophilic substitution, but it's not going to be D. Answer is C. Which compound decolorizes bromine water in the absence of sunlight? Definitely is not C. No double bonds. So how's it going to decolorize bromine water in the absence of sunlight? Here, well, benzene ring has electron delocalization. And what does that mean? Well, that means there has to be sunlight. There has to be enough energy to break the bonds, so it can decolorize bromine water. But there's no sunlight, so no energy, therefore it can't be B as well, because it's got electron delocalization. So it's either A or D. Well, A, if you look at A, CH3, CH2, CH2, Br, that's a halogen alkane. It's got no double bonds. And D, therefore D must be the answer. It has a double bonds. Which compound reacts to form a ketone when warm in the acidified solution of potassium dichromate? Well, to form a ketone, what must it be? Which compound reacts to form a ketone when warm in acidified solution? It's got to be a secondary alcohol. If we look at this, A, CCCOH, CH3, CH2, CH2OH. That's a primary alcohol. Therefore, it can't be A because it's a primary alcohol. B, well, let's look at B. So we're looking for secondary alcohol. We've got C, H, two methyl groups. So we've got CH3, we've got CH3, obviously a hydrogen here, and we've got C, CH3, CH3, CH, and obviously, no, done this wrong, haven't I? You've got CH3, C, CH3, H, OH. Well, this OH groups bonded to this carbon, which is not a tertiary alcohol, it is a secondary alcohol. Therefore it is A. It is B because it's a secondary alcohol. Secondary alcohol. Which does not contain an asymmetric carbon atom. What does that even mean? Which does not contain an asymmetric carbon atom. Which does not contain an asymmetric carbon atom. So that means which one contains a symmetric carbon atom. If you draw out A, CH3, CH3, CH2, CH3. Oh, this is symmetric. Isn't this symmetrical? Therefore it's A. It does not contain an asymmetric carbon atom with different R groups attached to it. It's got two methyl groups. Which reaction involves addition, elimination? Just how well you know your mechanisms. I just guessed this off the bat because I really like this nucleophilic addition elimination mechanism. This will react with potassium hydroxide. We never do the nucleophilic addition elimination. This, we've got an alkene. I'm reacting with chlorine. And this, well, what's happened? Well, this is nucleophilic substitution. These nucleophilic substitution. We just replace the Br with the OH group. C is CH3, Cl. That's the electrophilic addition. So we're left with A or B, and A is elimination. Yeah, it's elimination. Therefore, it must be B. So this question again shows you need to know your mechanism like that. Just by looking at equations, you need to know which one's this, which one's this, which one's this. 28. Which compound reacts with hydrogen bromide to give 2-bromo-3-methyl butane as the major product? Which compound reacts with hydrogen bromide to give this as a major product? Well, if you look at A, actually I'll leave this to last. Which forms a polymer with this? Well, it's got to be a diamine. You've got a diacyl chloride, so it's got to be a diamine. So it's just testing again your knowledge of it, but in a unfamiliar example. Which one's a diamine? It's A. 2 NH2 groups. That simple. Just need to know your mechanisms. Which structure shows a Zwitter ion of an amino acid? Well, Zwitter ion, again you need to know your definitions. It's got one positive charge and one negative charge, made up of 2 charges. And already I can see that has 3 charges. Can't be A. Again, B has 3 charges, can't be B. C has, so it can't be A and B, and I think they deliberately did that so you can eliminate half of them. So it's either C or D, right? Well, C, the charge is never meant to be here. If you know the structure, that's just your R group, and there's never supposed to be a charge in your R group, so it can't be C. Therefore, it must be D. And if you you could easily guess between C and D as long as you remember this fact. Only 2 charges for Zwitter ion. What is the minimum volume in centimeters cubed of this much we needed to oxidize that much of VO2 plus? I really didn't like this question, but if we break it down, so we're given what's the minimum volume a centimeter cubed of that much of KMNO4, you need to oxidize that much of VO2 plus. So we're trying to find out the volume of KMnO4 solution, we needed to oxide this much moles of this. So we've got 0.01 moles of this, 5 to 1 molar ratio. So we're going to divide that by 5. And that will give me the moles of MnO4 minus. 2 times by 10 to the power minus 3 moles. But how do I get the volume? Moles is equal to concentration times by volume. So volume is equal to moles divided by concentration. And we just found out the moles using the molar ratio. When we read the question properly, minimum volume of this needed to oxide that, so it's 5 to 1 molar ratio. The moles is 2 times by 10 to the power minus 3 divided by concentration was 0.02. That's the concentration of this, and that will give me 100. Therefore the answer is C. 32, which is concentration of NaOH in mole per dm minus cube as a pH of this. Given Kw, Kw is equal to H plus OH minus, and obviously what we're trying to find is concentration of this, so we can't, say H plus is equal to OH minus, because that will, therefore we'll just find out the concentration of H plus, but we can already do that. We're given a pH. H plus is equal to 10 to the power minus pH. H plus is equal to 10 to the power minus pH minus 14.30. Find a concentration of OH minus. OH minus Kw 1.00 times by 10 to the power minus 14 divided by concentration of H plus 10 to the power minus 14.30, and that will give me 2.00. Therefore the answer is D. 33. What are the units of the rate constant for third order reaction? Again, I don't really like this multiple choice question, but now I know how to do it. It's not too bad. First, construct the rate equation. Rate is equal to K, just a random one, so y cubed. Okay, we'll rearrange it. Rate constant K is equal to rate mole per dm minus q s to the power minus 1 over mole per dm minus cubed. Cancel out, you're left with s to the power minus 1 over mole to the power 2 dm to the power minus 6, which is mole to the power minus 2 dm to the power 6 s to the power minus 1, because they're denominators, so therefore it is D. Take 4. What is a pH this much of sulfuric acid? This one's a tricky one. It's got a trick. Sulfuric acid, if you draw it out, H2SO4. So we've got 2 H plus ions. So it's not monoprotic, it's diprotic. So, well, how do we find a pH? pH is minus log 10 H plus, right? If you just, concentrated class, you know this equation off by heart. And just does a practice. But what we need to do to this, because we've got 2 H pluses, we need to times this by 2. So therefore we need to do pH is minus log 10 of 0.015 times by 2. And that will give me 1.52. And obviously we want it to 2 decimal places, pH 2 decimal places, and all of them are given to 2 decimal places. So therefore C. However, if we did minus log 10 of 0.015, we'd get 1.82, this one, but that's wrong. It's got 2 H pluses, so that's tricky part. 35. Which compounds form when phenyl benzene carboxylate is hydrolyzed under acidic conditions? Phenyl benzene carboxylate. hydrolyzed, we've got water, adding water. This H is going to go here, this OH is going to go here, so we're going to have OH, we're also going to have that, the carboxylic acid group. So the answer is D, that's the compound form. C6H5COOH. Now, definitely not B, that is not an alcohol group, that is ketone aldehyde. Definitely not C. So it's A or D. Well, A, you've got C6H5, which I agree with, is CH2OH. That, we don't have that here. We've just got your C6H5OH. It's got to be A. And this one, we've got C6H5COOH. That one must be D. Shouldn't rinse the apparatus before starting an acid-base titration. The results of titration showed that the volume of acid added from the burette was larger than expected. So they showed that the volume added from the burette was larger than expected, which is a possible reason for this. The conical flask was rinsed with water before the titration. That's fine. The walls of conical flasks were rinsed with water during titration. That's also fine. The pipette was rinsed only with water. That's fine. The burette was rinsed only with water. That will dilute the acid. And that is not fine. And that is the reason the results showed that the volume of acid at the burette was larger than expected. And now let's go to the last question on this one. I might not get this correct, guys, so yeah, but let's see. So CH3, so we've got C double bond C, CH3, CH3, your H, and your CH3. The hydrogen bromide. Double bond here, here. Right, and we get CH, we get C, CH3, CH3, H, CH3, positive charge, Pr minus, no pair of electrons bonds to it, right? CH3, C, CH3, H, CH, CH3, Pr. What did we form? 2-bromo 3-methyl butane. 2-bromo 3-methyl butane. Yeah, that's what we formed. 2-bromo 3-methyl butane. Methane, ethane, propane, butane. Yeah, the answer is A. Pretty sure. That is the end of multiple choice questions.